Wow, the types of
power that they make are electric and hydroelectric. Its uses are hydroelectric power creates electricity. The dam used to create the power creates water control. And it can be found in Canada, France, Italy, Russia, and Japan. Waterfalls and large streams and rivers, those are the main places. But small ones can also be found all over the world. It's obtained through a process when the water goes through the dam. This process, first there has to be a dam to stop the water and create an artificial reservoir. When the dam is opened, water travels through penstocks or pipes to the water house. From there, the water falls into turbines, which turn and creates electricity through the generator. The electricity then goes into a substation, which contains transformers and switching facilities. It makes low and then makes the low voltage power to high voltage power.
Okay, hydroelectric power plants are used to create this electronic turbine. Advantages of hydroelectric power is that it's effective, efficient, it's clean, it controls the water, and it has low cost maintenance. The disadvantages of the hydroelectric power is that it's high construction costs, but since it's low maintenance, it pays off in time. But and also, if it's drought, basically useless. The environmental impact is that it creates lakes and very little pollution, and it's currently used in the United States, Russia, Canada, Japan, France, Italy, Spain, West Germany, and the United Kingdom. The United States uses the most hydroelectric power. Building costs for plants are high, but the maintenance cost is low.
This is a poster. Here the water travels through the turbine to goes out. Here a generator of the Lance tidal works in France is encased in a steel bulb centered in the water passage. This is the top of the turbines in the actual plant. This is the powerhouse in Canada. This is a picture of the dam. Andrew.
Yeah. Basically, this is the turbines, and which way the water flows. And when the water comes in, it turns the turbines, which make a steel, which is basically electricity, and then it's channeled out into the world, and the excess water flows out into below the dam.
This is a model of the dam. Here's the dam which creates the artificial reservoir. The water flows down through the lakes. They only open a couple. So it creates a smaller lake down there, and it starts emptying out in the turbines and goes down into here, and this is the powerhouse. And then this, we have a small generator, and what it's only part of the hydroelectric plant, and this crank right here, and what would happen is the turbines would be connected to this, and when the water flows through the turbines, it would spin this, which creates electricity. You can't tell it.
Can you show it?
No. Oh, a light bulb like.
Okay.
I'm trying to make it.
We did natural gas and the history of natural gas. William A. Hart dug the first well of natural gas, and he piped it up and used it to like shafts. And natural gas uses are detergents, drugs, fertilizers, paints, plastics, rubber, and nylon. And places natural gas is produced is every continent in the world but Antarctica.
amount of gas, and it burns clean. The fine natural gas is like formed by tiny marine creatures that are like decaying at the bottom of places, and it's trapped in porous rock underneath non-porous rock. And the trapped matter becomes gas, oil, and water, which are petroleum products. Then the big pipes drilled down through the porous rock to get the natural gas, which is on top of the oil. Some advantages of natural gas is that it burns clean and may someday replace coal and oil. Disadvantages of natural gas is that leaks can cause explosions, and it's not a renewable fuel. Not renewable. The environmental impact emits less carbon. Well, natural gas emits less carbon monoxide and less carbon dioxide than gasoline does, and it burns cleaner than coal. So it's virtually clean and less impact. Gives less impact to the environment.
This is a bolster, and this is like a natural gas tank transporting natural gas.
This is a natural gas pipeline, and that's the taxi cab route.
This is how it is formed natural gas.
And up here are more pipelines. Oh, down here is William Hart's like oil drill pump thing when he first pumped the oil. And this is like the life cycle of natural gas. Down here it is drilled up from underneath the porous rock and is brought to the pumping station, which is there. And it's like,
Waiting station.
yeah, it's like transferred up into these pipes and distributed among your community. And in the community it's distributed through meters and burners.
That's like the that guy. Sorry, William A. Hart. He puts natural gas.
Up here is a natural gas controlling station. This here is a graph that shows oil use. The oil use is in the black, and natural gas is in the lighter black, lighter gray sort of, and it's like less costly. And as
These are
like
just
the
more
years
pipes.
go on,
These are just like pipelines that are in built in like England, Holland, France, Austria, Italy. Those are just pipelines out there.
and this is an example of a burner. It's like natural gas comes through an outlet there and burns there. And natural gas can be used in like heaters like this for your house, or like stove in your house, a dryer in your house, and even hot water heater. And you can, when you buy these things, you can either have a choice of natural gas or electric.
Nuclear energy. Nuclear energy can also be referred to as atomic energy. This is the powerful and strong energy that is released by changes in the nucleus of atoms. Various amounts of energy can be produced by nuclear energy. Some examples are the heat and light of the sun, which is produced from nuclear energy. Scientists have found substantial amounts of ways to form uses from this energy. There are many more examples, but some of the most important are
strong force. A very large amount of energy is concentrated in the nucleus because of the huge amount of force. The last step was the force nuclei of much of that energy. The first release of nuclear energy was at the University of Chicago in 1942. After this scientist developed the idea of an atomic bomb, this bomb helped us win World War II. The energy that is released by the nuclei makes huge amounts of heat.
The heat is then used to make steam, which could be used to generate steam, and steam is used to cause electric energy. Engineers have found a way to build nuclear reactors, which controls and produces nuclear energy. A reactor can be preferred to operating like a furnace. The reactors use uranium, which is odd because they don't use coal or oil. They don't burn in a reactor. Its nuclear then splits into two. As soon as the nuclear split, it releases energy, which is made into heat. Fission of 1 pound of uranium can produce burning of 1,140 short tons of coal. There are many important uses of nuclear energy. Electric power is definitely the most important use of nuclear energy. Nuclear energy is also used to power submarines and ships. The fission that creates nuclear energy is very important because it releases particles and rays that are used very much with its industry, science, and medicine.
Nuclear energy has a very important role in power production. Very few countries have enough water power to produce very big amounts of hydroelectricity. Many of the countries depend on fossil fuels. Fossil fuels are non-renewable resources. Many people predict that nuclear power will become extremely popular in the near future. The worldwide distribution of nuclear energy is very much alive. In the mid-1900s, approximately nuclear power reactors were operated and used in about 30 countries. Nuclear power plants have made less than 20% of the world's electric energy. The United States was the top of the world's largest producer of nuclear energy and had the high number of about 110 nuclear reactors. The reactors were so important because they produced about 20% of the country's electricity.
The advantage of nuclear energy over fossil fuel plants. One of the advantages of nuclear energy is once the plant is built, it is less expensive to operate. The reason is a nuclear plant uses a very big less amount of volume of fuel. The second reason is not like fossil fuels, there is no solid or chemical pollution into the air. Nuclear power plants have three very big disadvantages. Nuclear plants are more expensive to build. The amount and need to promise that very bad amounts of radioactive materials aren't distributed into the air. The dangerous radiation lives after removed from reactor. After you remove from reactor from used nuclear fuel.
Many careers are produced by nuclear energy. In 1972, the discovery that a natural chain reaction released nuclear energy into uranium deposits in West Africa 2 billion years ago. Back then, there had been not much radioactive decay. There was accumulation of groundwater was acting as a moderator, which started the reaction. Heat from the reaction made steam from the water. Litterer building consists of electric generators and turbines. Just about every plant has facilities by which storing used fuel. Most of energy plants have a main control room, a containment building, and reactor building. It has the thick walls of steel or concrete lined with steel and a thick concrete floor. The concrete and steel guard holds the escape for radioactive material from a leak in the nuclear reactor.
And this is a picture of like the control room at the Fort St. Vrain nuclear generating station. And then
Everything's operated from that room, basically.
and then this is like how nuclear reactors work. And they work. The first step is reactor core. Reactor core radiates heat through the splitting of uranium atoms. And then pressure, water, and the primary loop carries heat to a steam generator. And then the steam generator vaporizes water in a secondary loop to drive the turbine. And then
All the steps it goes through.
this is the nuclear reactor.
This is a nuclear magnetic resonance. It has like one of those, what you call it, one of those like things that grasp the different movements and stuff of the nuclear reactors. And this is a nuclear reactor in 605 and all the steps and like there's a lot of labels. It shows the labels like everything and all the parts and everything. But there's
Oh, I think we have that in our book, too.
And this is a handling flask for irradiated fuel for a Dragon reactor of Winthrop, England. It's like an experimental high temperature. It's called like Petroleum cooled. It's graphite moderated. It's a graphite moderated reactor.
Just moving air that is found all around us. There are many different types of wind, and every one of them has meaning. The most constant winds are the trade winds. These winds blow towards the tropics, where warm air rises and blows most of the year round. Unlike a tornado, a breeze is a light wind. A tornado is a terrifying wind that destroys everything in its path. It rushes across the land, sucking up every object in its way at speeds of 30 to 65 kilometers per hour. Then there's a hurricane, which is a violent storm with winds that can blow at over 320 kilometers an hour. Hurricanes start out at sea, then work their way inland, bringing torrential rain.
Great, Diane. Also, wind is measured by using the barometer. The Buford scale to see how fast it's blowing. Wind direction is measured using a wind vane. The arrow of the wind vane always points the direction the wind is blowing. Another way wind speed is measured is by the anemometer. The faster the wind blows, the faster the cup spins. The windmill is a rimless wheel that has vanes or blades for spokes. Like the water wheel, it's mounted on an axle. As the wind blows in the vanes, the wheel rotates the axle. This motion is then transferred by the axle to a drive shaft, which turns millstones to grind grain or other devices to perform work. Windmills can generate electricity or pump water. Wind power is free of cost and there is no pollution. However, the equipment needed is very costly.
And this is an example of the windmill. This is the anemometer, which measures the wind speed, and the faster the wind goes, the cup spin around. This is the wind vane, which shows you the wind direction by the arrows point to the west. This is a windmill. This is a hurricane.
And most of the wind currents are formed near the equator because it's very hot there and it rises. There's some move off to other northern or southern areas, but some just stay there. That's why it's very hot there. Some just doesn't move.
Okay. And the weather people use
very little amount, so it takes fields of them and concentrate to produce the energy that a nuclear plant or another kind of that structure could, and it's still windmills. And these are winds that shows the circulation of them, like around an area. The trees can stop that flow when you're diverted.
There are other names for petroleum as oil, black gold, and crude oil. Petroleum is thick, dark liquid that is made from hydrocarbons. Oil is also contained of compounds of nitrogen, sulfur, and oxygen. Oil is a non-renewable source. Experts estimate that oil reserves will last for the next 40 or 60 years. Petroleum has been collected for years. Early Americans used it for warfare, shooting arrows tipped with burning oil. It was formed by dead small animals jumping to bottom of the ocean millions of years ago, covered with mud, and by the time it was dissolved into layers of sedimentary rock. There, it was the pressure from the sedimentary rock eventually transformed to petroleum. Petroleum is almost everywhere. All automobiles use petroleum. It is also used in makeup products, washing detergent, dyes, and anti-icing products for snow. This product is made, the crude oil is made from the fractional power. Oil is taken from the earth in a refinery. The refinery is a large industrial plant that separates crude oil from into the products such as gasoline, fuel oil, heating fuel, petroleum jelly, and asphalt. Petroleum has many uses. For instance, you can burn petroleum to make energy. Some items that can be made from petroleum are paint, phonograph records, explosives, fibers, antifreeze, food containers, furniture, appliances, food clothes, and shoes. Petroleum can become like a black tar, and it can be used for like, filling up cracks in ships. And it's also used for ways of transportation in cars, trains, buses, and airplanes. And petroleum is obtained by digging a well under the sea. And the petroleum is usually formed under the sea by dead organisms. And if there's a fault or a crack in a rock, it may be obtained there also. And it can be obtained from oil shale. And the advantages of petroleum are that it's used in many items that we use every day. And it's used for like fuel in cars and airplanes and automobiles. And it's a fossil fuel. And the disadvantages of petroleum are that it pollutes the air, and it can cause oil spills and pollute the ocean. And it's not renewable since it's a fossil fuel.
With a fractionation powered, the petroleum undergoes fractional distillation. The oil is heated into a gas with rising in the fractionation tower. The product contained in the crude oil vapor has rock usually black but sometimes brown. It's one of Earth's most useful minerals and one of mankind's primary energy sources. It burns easily and gives off a lot of heat. Coal played an important part in the development of industry since the 1700s. The most important use of coal is to run electric power. When coal is burned, it produces useful heat that people can use to heat buildings or for electricity. However, the burning of coal is a major cause of air pollution. Coal miners have died from lung diseases from breathing coal dust.
There are many uses of coal. Some coal is simply burned as fuel, not only in household fires, but also in power stations to produce electricity. A lot of coal is also turned into coke. In this process, coal is baked, not burned. Gases given off from baking coke are collected and used to make a number of important chemicals. Coal produces electric energy for power plants, and it also produces heat energy. Coal is also used, like in old days, to run locomotives and to make them hurt. Coal is found on every continent. It is found as far north as the Arctic and as far south as Antarctica. Some coal deposits occur off ocean coastlines, but however, deep ocean deposits have little value at the time because they're difficult to mine. Coal deposits that can be mined and profitable are called coal reserves. A large area of tested reserves is also called a coal field. Most of the proved recoverable reserves are in Australia, China, Germany, India, Indonesia, Poland, Russia, South Africa, and the U.S. Half of all the U.S. coal reserves lie in the eastern half of the nation, from the Appalachian Highlands to the eastern edge of the Great Plains. The rest of the reserves are in the western part of the country. Canada's reserves are in the country's western provinces, such as British Columbia, Alberta, and Saskatchewan. Coal is produced, processed,